All right, I'm doing set A for my reteaching, and I am estimating. So I'm looking to see whether the numbers, I'm going to use some benchmarks here. Is it closer to 0, a half, or a whole? So number 1/3 is, or two-thirds is closer to 1/2. The book is saying. I would say it's closer to 1, but you could either have 1/2. 5/6 is very close to 1. You get 1 and 1/2. Or you could say 1 plus 1 is 2 on that one. I would take either one. For number 2, 7/8 is really close to 1, minus 5/12. And we know for 12, 6/12 is a half. So this is actually under a half. So I would say 1 for number 2. For number 3, 1/8, any unit fraction is going to be a 0. Anytime there's a 1 in the top, it's a 0 plus a 0 equals a 0. 5/8, 5/8 is bigger than 4/8, so it's bigger than a half, so it's closer to 1, minus 1/6, which is that unit fraction. We call that a 0. And we've got 2 unit fractions down here, 1/5 and 1/3 is close to a half, or you could have it as a 0, either way. 11/12 is very close to a whole, and 1/10 is really close to 0. 9/10 is close to a whole, and 1/5 close to 0. 3/5 is closer to a half, or you could say a whole on that one. Either way. And that's set A. For set B, you're going to find the common denominator and rename the fractions as an equivalent fraction with a common denominator. So 5 and 10, an equivalent fraction, find a common denominator and rename. For these guys, you could do it a couple different ways. You could say 3/5 and 7/10. You can multiply them together and rename them with 50 as a denominator. So you could rename as 30/50 and 35/50. You can also say 3/5 and 7/10 can be renamed as 6/10 and 7/10. I left that one alone because I know I can rename by multiplying 3/5 by 2 over 2, I will get tenths. So my common denominator could be a 10 on that one too. For 5/6 and 7/18, I could, if I wanted to, 6 goes into 18, so I could just leave that one alone and change 5/6 to 15/18. So my common denominator could be 18 on that one. I definitely wouldn't want to multiply 18 times 6. That would be a huge number. So, and 6 goes into 18, so you really only need to rename one fraction. And for number 3, I have 3/7 and 1/4. On that one, I could multiply the denominators together because that is the first number I will say when I skip count by 7s and 4s. I will say 28. So we're going to have to find equivalent fractions here. So our common denominator is 28, and our new fractions are 12/28 and 7/28. All right. Now we're moving on to set C. You can find it here. There we go. For set C, we're going to multiply the numerator and the denominator by the same number when writing an equivalent fraction. So we're actually going to be doing some math here, adding things up or subtracting with, and we're going to need to sometimes rename our fractions. So again, they're different, but 5 goes into 10. So I can leave that one alone. I only have to change 2/5. 5 times 2 is 10, so 2 times 2 is 4. So I add that up. For number 1, I get 7/10. For number 2, I have 1/9 plus 5/6. Denominators are both different, so I'm going to have to rename both of them. When I count by 9s and count by 6s, the first number I say that they have in common is 18. And 9 times 2 is 18, so 1 times 2 is 2. 6 times 3 is 18, so 5 times 3 is 15. 15 plus 2 is 17, 17/18. And that is our final answer. Number 3, 3/4 minus 5/12. 4 goes into 12, so I'm going to leave that 5/12 alone. And I only have to rename the 3/4 into 9/12. Don't forget to follow your operation. This one is subtraction, and I know that 4 goes into 4 and 4 goes into 12, so I can actually reduce that to 1/3. Number 4, 7/8 minus 2/3. 8 times 3 is 24, and that is the first number that I will say when I count by 8s and count by 3s. So 3 times 8 is 24, so 2 times 8 is 16. 8 times 3 is 24, so 7 times 3 is 21. And when I subtract, I'll get 5/24. For number 5, 1/12 plus 3/8. I don't want to multiply 12 times 8. That's huge. So I'll count by 12s until I find something 8 goes into, and 24 works. Equivalent fraction, add, and bring my denominator down for number 5. And for number 6, 4/5 minus 2/15. 5 goes into 15, so I can leave the 2/15 alone. And I'll wind up with 10/15. And I can actually reduce that into lower terms to 2/3, but 10/15 would be fine. And for the last one, number 7, Teresa spends a third of her day at school, a 12th of her day eating meals. What fraction of the day does Teresa spend at school or eating meals? I think that means and eating meals, but okay. So we're going to find equivalent fractions. I know that 3 goes into 12. So we wind up with 5/12 of her day she spends eating meals or at school. Okay, that was A, B, and C.